example 2, we're going to start with B as a review of what we did last video, last homework. Example 2 is a reminder. This is factoring by one of the methods that we use to factor polynomials, which you're already familiar with because it's factoring by grouping. So the next example that we're going to look at is negative 2 x cubed minus 4x squared minus 3x minus 6. Again, with polynomials, we have a cubic here. If you have 4 terms, factoring by grouping is the first thing that you should try. Because there's 4 terms, it doesn't fit one of those special factoring patterns that we talked about, like the sum of cubes, these ones, sum of cubes, the difference of cubes. It doesn't fit either one of those because there's more than 2 terms. So there's 4 terms, factoring by grouping is usually the way to go. We're going to group the first 2, group the last 2. Greatest common factor of the first grouping is actually negative 2x squared. You're left with x minus 2. In the second grouping, your greatest common factor is negative 3. You're left with x, oops, sorry, that should be x plus 2. X plus 2. Because the parentheses are the same, you can put your greatest common factors together. And then the x plus 2. Now, this is still quadratic, so I told you when we did this problem that you always have to double check and make sure that you've completely factored. So like, up here we had the x cubed minus 8. Well, that's the difference of cubes, so I had to go further and factor further. Here, that's not a difference of squares because I can't take the square root of either 2 or 3, so that's where I stop, and that's the last factorization I can do. Okay, we're going to move on to example 3. For example 3, make an A and a B. And this is the other type of polynomial that you'll see. So when there's 4 terms, you always try to factor by grouping. When there's 3 terms, or when there's 2 terms, for example here, you don't have a cubic, then you look to factor it like you would something that would be a quadratic. Now, because we have 2 terms here, and you're subtracting, and it's not a cubic, I might think, well, let's see if it fits the difference of squares pattern. And then I would ask myself, can I take the square root of the first term, which I can. It'd be 5x squared. Can I take the square root of the second term? Yep, 6. Alright, so it fits that pattern for the difference of squares. And so your answer here would be 5x squared minus 6, 5x squared plus 6. And again, you just have to double check, can you break that down any further? In either case, well, this would be the only one that we could break down further because it might be a difference of squares, but I can't take the square root of 5 or 6, so that's where I stop. Okay, and then for B, I'll look at another one. Alright, now this one has 3 terms, and it has an even degree. In this type of problem, if you're told to factor it, because every term has x's with it, I might try first to see if I can simplify it by pulling out the greatest common factor right off the bat, which in this case ends up being 4x squared. So I'm going to pull that out in front. I'm left with x to the 4th minus 5x squared plus 6. Now, when I look at that trinomial, it kind of looks like a quadratic. Like a quadratic might look like this. The only difference between a quadratic here and this quartic is you've doubled your exponents in both cases. But because they look similar, we can factor this one like we would a quadratic. So with a quadratic like this, we would look at it and say, oh, well, there's no number in front of x squared, so I'm going to start with 2 parentheses. Same thing here. There's no number in front of x to the 4th, so I'm going to start with 2 parentheses. And then what times what would give me x to the 4th? I'm breaking it down. Well, x squared times x squared would give me x to the 4th. And then I'm looking for 2 numbers that multiply to get 6 and add to get negative 5. Those 2 numbers might be negative 3 and negative 2. So again, you have to just double check and make sure that all of your parentheses are broken down as much as you can. In either case, you have a subtraction sign, so you might need to just check and see if those are difference of squares. But you can't take the square root of 3, you can't take the square root of 2, so I think you're pretty safe. Now let's say I change this problem to solving. Once you factor, like we've done in this case, to solve, you're going to take each parenthesis or expression and set it equal to 0, just like we did with quadratics. So I'm going to set 4x squared equal to 0, because that's my first piece. X squared minus 3 equal to 0, and x squared minus 2 equal to 0. And then in each case, I'm going to solve for x. So here when I solve for x, if I divide it by 4, you get x squared equals 0. So x is going to equal 0, because the square root of 0 is just 0. In this case, and actually 0 would be what we call a double root. I don't know if we've talked about that. I think we have talked about it. When you get an answer twice. Yeah, we talked about that. Like with quadratics, when we got an answer twice, it represented the vertex on the x-axis. So here I'm going to get this answer twice because you take the square root, and remember whenever you take the square root, you have like the plus or minus. We're not going to stick plus or minus on 0 because 0 has no value, so it doesn't really make sense to do that. But we do know it occurs twice, so we'd put a double root. In this case, move the 3 over, take the square root of both sides, you get plus or minus square root of 3. Same thing over here, take the square root, and you get plus or minus square root of 2. Now if I count up my answers, I have 1, 2, 3, 4, 5, 6. Okay. Now remember what your answers mean. Your answers mean the same thing here that they do when we are solving quadratics. Your answers represent the x-intercept. So in this case we have 6 answers. I also want you to pay attention that we had a 6-degree polynomial. This leads into another section that we do later on, but the degree of polynomial that you have, so if we had a 5th-degree polynomial, you'd have 5 answers. If you have a 3rd degree, so if you have a cubic, you're going to always get 3 answers. So it's always good to double check and make sure you have the same amount of answers as the degree, and then you know that you did it right. Alright, go ahead and flip. Example 4 is going to be similar. We're going to look at 2x to the 5th minus 18x equals 0. Now this is a solving one. At this point, the only way that you have to solve a polynomial is by factoring. So we're going to start by the same step that we start with every time, which is pulling out the greatest common factor. So let's do that. We can pull out a 2x, I think. You're left with x to the 4th minus 9. Okay. Then also remember with factoring that you always want to just double check and make sure that you've broken it down as much as possible. This might be a difference of squares if I can take the square root of both terms. The square root of x to the 4th is x squared. Square root of 9 is 3. So that does fit this difference of squares pattern. So I can break that up one more time. Okay, because I'm solving, now that I've broken it apart into every factor that makes it up, I can set each factor equal to 0 and solve for x in all the cases. So I'm going to set 2x equal to 0, x squared minus 3 equal to 0, x squared plus 3 equal to 0. In this case, x will equal 0. In this case, we're going to have a similar situation as we had on the other side of the page, and you get x equals plus or minus square root of 3. In this case, you get plus or minus square root of 3i because you have an imaginary term. But we should have 5 answers because I had a 5th-degree polynomial. Count them up. 1, 2, 3, 4, 5. So those are my answers. Alright. Let's flip through here. Okay, I think we have enough time to do example 5. Alright, for example 5, and we're going to have some practice on this in class well with partners. And I'll probably go through another example like this with you. So just do the best you can. I would suggest watching this example at least twice just so you kind of get in your mind, because this is a standard all by itself, is that you are able to solve the volume type problem with polynomials. All right, an optical company is going to make a glass prism that has a volume of 15 cubic centimeters. The height will be h centimeters. The base will be a right triangle with legs of length h minus 2 and h minus 3. What will be the height? All right, so you have this figure, this glass prism. Tells you that the height will be h. So like this is laying on its side right now, but that would be considered the height of the object. The base is a right triangle with lengths h minus 2 and h minus 3. And then we're supposed to figure out what the height is. Now, in general, with volume is always the area of the base. So if we had a square base, or we had a rectangular base, or we had a circle base, it's always the area of whatever the base is times the height. So that formula is basically how you would set up every single volume equation, no matter what the base of the object is. Alright, so it doesn't give me a volume. It tells me to find it does give me a volume. So I'm going to plug this 15 in for V here. Well, actually before that, sorry. The area of the base. Let's get the formula for that, because the area of the base here is specifically a right triangle. The area of any triangle is 1/2 base times height, in that case. And then the height of the object, because we still have to multiply by that. Let's go ahead and plug in what we know. I know the volume is 15. That 1/2 is there. I know the expression for the base, the way I drew it, is h minus 3. The expression for the height of the right triangle is h minus 2. And the height of the object is just h. Now, if I want to set this up so that I can solve, I need to get everything over to one side, like I had for example 4, because that's like one where we actually solved through it. I need to get everything on one side and get it equal to 0. Notice that whenever we solve, like for example 4 and example 3, there are no parentheses when you go to start solving. Parentheses don't occur until you do start to solve and factor. So I have parentheses here. I have to simplify this and get everything over on one side and get it equal to 0. I really don't like that fraction being there. So what I'm going to do right off the bat is multiply everything by 2, and that'll get rid of my fraction. So I'm going to get 30 equals h minus 2 times h minus 3 times h. To simplify over here on the right so I can move everything over, I'm going to FOIL those together. Outer and inner give me -5, 6. But I'm going to distribute that h through. And then the last thing I would have to do before I start to solve is move the 30 over. Because whenever we solve, you need a good starting place, and this is our good starting place since we're going to be solving by hand. Now, in this situation, you have 4 terms. So, like I stated before in these notes, whenever you have 4 terms, you want to try and see if factoring by grouping works, which in this case I think it will. So we're going to pull out the greatest common factor in the first grouping, which is just h squared. The greatest common factor in the second grouping is 6. So my factorization is h squared plus 6 times h minus 5. Now, every time we've gone to solve, once you factor, you set each factor equal to 0 and solve. So I'm going to do that over here. Okay, so in the first scenario, when I set h squared plus 6 equals to 0, I get h squared equals -6, so h will equal plus or minus square root of 6i when you solve it, when you take the square root of both sides. You can't have a height that's imaginary, so that one actually, even though I could solve it and get an answer, actually 2 answers, we can't use this for this particular problem because it doesn't really represent a height for us. So in this case, when I solve h minus 5, I get h equals 5. That is going to be my actual height. And that is what the question asked for. It didn't ask for the dimensions, it just asked for the height. So that would be my final answer. Now, because this is a dimension type problem, probably some units, which in this case are centimeters, I would expect to see that as well. Okay. So tomorrow we will be working specifically on these types of problems with 4 terms. We'll be working a little bit more with difference of squares, even though we've gotten some practice on that. And then quadratic, what we call quadratic form, which those are ones that kind of look like quadratics even though they're not, but we can factor them like we would quadratics because they follow the same pattern. And then we're actually going to be solving too. But that's all stuff that you've done, like you've done factoring by grouping, you've done solving, you've done this. Really the only piece that's going to be totally brand new to you is maybe this one, but again, it's not totally brand new because you've factored quadratics before. It's just taking it one step further. And then we'll obviously be practicing things like example factors. So we're done.